Hey, क्या चल रहा है? A very good evening to everybody watching this video. ये should be the last session of electrochemistry जो मैं आपके साथ करूँगा theory wise. Well, unless somebody really wants me to do the batteries part, I feel काफी theoretical है. Sure, कुछ ideas हैं उसमें जिसमें दिमाग लगाना पड़ेगा. Of course, because redox reactions का ही application है, especially secondary batteries का, right? What happens when you charge the battery? What happens when you recharge the battery? वो सब आप पढ़ना पड़ेगा जरूर. I have done some sessions on the JEE channel उस पे already, उसके questions पे, तो if you want to go check that out. But keeping that aside, according to me, this should be the last session. We're going to cover Kohlrausch law. हम लोग एक दो सवाल पहले करेंगे, and then we'll go ahead and figure out Kohlrausch law and independent migration of ions, all of that. ठीक है? Cool. And this part is always tested. So I know that कि electrochemistry को काफी students को लगता है कि भारी चीज है. But if you just do the second part of, I would advise this, but if you just did the second part of electrochemistry, you'd be good. You'd be really good by getting those marks there. ये है और Faraday's law. That's all you need to do. खैर, are you able to hear me? मेरी आवाज साफ आ रही है? Can you see me? Just let me know in the comments. मैंने आपको क्वेश्चन दिया था कल. Yeah, we met just yesterday. It was a time different from our regular times. I know. It got a little hectic for me the day before, so I moved the Thursday session to Friday. Check it out if you haven't. This is the last session. Okay, Faraday's laws मैं कर चुका हूँ. I've also done क्या बोलते हैं इसको? The last session where we started conductive ionic solutions, we did that just yesterday on Friday. That was part 6. This is part 7. Okay. आज हम लोग Kohlrausch law की बात करेंगे. Okay. Wait, hold on. I completely forgot. Hi, good evening, Mehak. Let's look at NCERT, है ना? पहले NCERT देख लेते हैं, उसके बाद हम लोग बाकी सब चीजें करेंगे. Let's go. NCERT में देख लेते हैं क्या क्या बाकी है. Here you go. Right? ये सब चीजें हम लोग करेंगे, आज करेंगे. कल क्या किया था? We stopped here. Around here is where we finished yesterday. मेरे सर के पीछे आ गया. व्हीटस्टोन ब्रिज से यू कैन फिगर आउट कि ठीक है, ये जो सेल आप डाल रहे हो उसकी क्या कंडक्टिविटी होगी. वी डिफाइंड कापा टू बी कंडक्टिविटी जी स्टार बाय आर और जी स्टार इनटू जी. व्हाट इज जी स्टार? जी स्टार वाज एल बाय ए व्हिच वाज सेल कांस्टेंट. ठीक है, प्लीज पढ़िए एनसीईआरटी इफ यू हैवंट ऑलरेडी डन दैट. टुडे वी विल टॉक अबाउट मोलर कंडक्टिविटी. Actually, in a way, I spoke about this already. ठीक है, मैं आपको थोड़ा बहुत hints already दे रहा था. If you caught it on that, great. If not, don't worry. We'll talk about molar equivalent conductivity, and then we'll go on to look at these graphs. Yeah, variation of molar conductivity with concentration. This is a strong electrolyte. This is a weak electrolyte. I feel actually ये थोड़ा सा गड़बड़ है. ठीक है, मेरे हिसाब से it should be this. It should be this and this, and not. I don't think it ever goes higher. Right? This is just this is what I have seen in other places, but NCERT has done this, so. Yeah, we got to put what's in NCERT. यहाँ पे ऑनलाइन वर्जन है तो just saying E, but it should be lambda not. Anyway, चलो शुरू करते हैं. ये सब हम लोग आज करेंगे. Cool. Hi, Abhinandan. Okay. He wants to be funny. What was the electrical resistance of a column of 0.05 mole per liter NaOH, solution of diameter 1 centimeter and length 50 centimeter? ये सब हम लोग किस चीज की बात कर रहे हैं? Maybe you have some system that looks like this. A diameter 1 centimeter, मतलब कि ये पूरा this is 1 centimeter. Okay. And बाकी क्या क्या चीजें हैं इसमें? Length 50 centimeter. मतलब ये तो burette जैसा हो गया. Okay, I can't draw this. ये तो burette जैसा हो गया ना, 50 centimeter length. It's pretty long. Okay. So उस पूरे कॉलम का रेजिस्टेंस क्या होगा? Well, I know that resistance is rho L by A. बट मुझे ये सब वैल्यूज दी नहीं है. क्या क्या दिया हुआ है? अच्छा, रेजिस्टेंस दिया हुआ है. ओके, और रेजिस्टिविटी और कंडक्टिविटी निकालनी. ठीक है, निकाल लेंगे. इफ यू गेट रो, यू गेट, वेल दैट्स रेजिस्टिविटी, एंड कंडक्टिविटी इज 1 बाय रो, राइट? दैट्स कापा. वी कैन डू दिस, कांट वी? ओह, दैट्स क्रेजी. दैट्स ग्रेट, अभिनंदन. यस यस, बिल्कुल सही आयुषी. गुड टू हैव योर इनपुट हियर. बिल्कुल सही बोला. कैन यू गो अहेड एंड कैलकुलेट दैट एंड टेल मी व्हाट द आंसर वुड बी? जल्दी से करके बता सकते हैं? लुक्स लाइक ये कंसंट्रेशन की जरूरत नहीं है. नॉट नीडेड. इंटरेस्टिंग. अभी तक तो जरूरत नहीं है, आगे बढ़ेगी तो बताऊंगा. इसमें तो जरूरत नहीं लग रही है मुझे. व्हाट डू यू थिंक अबाउट दैट? हाँ. और रेजिस्टिविटी का लेंथ, ये यूनिट क्या होगा? ओम, सेंटीमीटर. इट इज ऑल्सो ओम मीटर, बट यहां पे सिंस सेंटीमीटर दिया हुआ है तो वी विल डू दैट. कंडक्टिविटी का क्या होगा? इट विल बी सीमेन सेंटीमीटर इनवर्स, और मो सेंटीमीटर इनवर्स, और ओम इनवर्स सेंटीमीटर इनवर्स. दिस इज गोइंग टू बी कापा, राइट? एंड दिस इज रेजिस्टिविटी. प्लीज ट्राई करिए, प्लीज ट्राई करिए. आयुषी ने बिल्कुल सही फॉर्मूला बताया. I'm going to write down what आयुषी said. R equal to rho L by A, जो चीज बताई उन्होंने. ठीक है, यह जो सब्स्टिट्यूट फ्रॉम हियर, कोई रॉकेट साइंस है नहीं. R की वैल्यू 55.55 है और इज 5.55, सॉरी 10 पावर 3. is equal to rho into 50 by pi into 1 by 2 whole square. Why 1 by 2 whole square? क्योंकि दोस्तों डायमीटर दिया है यार, रेडियस इज गोइंग टू बी 1 by 2, ठीक है, और you can also do pi d square by 4, it's the same thing, ठीक है. That's what I've written. I've done this, I've done pi r square. It's exactly the same thing. It doesn't matter what you do. Either way same answer आएगा. तो इसको कैलकुलेट करने पे you get pretty high value. Yeah. अभिनंदन, अगर आपको टाइम पास करना है कहीं और, यहाँ पे हम लोग इलेक्ट्रोनेगेटिविटी सॉरी वी आर डूइंग इलेक्ट्रोकेमिस्ट्री यहाँ पे. इफ यू वांट टू डू टाइम पास, कम टू डिस्कॉर्ड, जितना बात करनी है करिए, आपके बहुत पेयर्स होंगे who will answer whatever questions you have. Yeah, you know where the links are, they are all pinned. Go to the bento link, go join the Discord and Telegram groups. All right, good. So yeah, this is the value of rho. Ayush, did you get this? Anybody else trying this well? Mehak, are you trying this? Yeah, I know the numbers are a little scary, but I think you can approximate stuff and get to that. How? Dekho, this pi, which is 22 by 7. Shall we try that out? Let's try it out. 5.55 into 10 power 3. दूसरी जरूर करते हैं. Let's do it here. 5.55 into 10 power 3 into 22 by 7 into 1 by 4 divided by 50. This does not look very nice, does it? 4 into 50 becomes 200. 22 and this thing, let me say this goes 10 times. No, this is not looking very nice. This is not looking very nice. 22 by 7, not by 1. Huh? So it is basically, yeah, it is 55 by 70. So I'm getting around 80. 56 by 7, I'm getting around 80 by this weird approximation. 80 के आसपास आ रहा है. The actual answer is 87. ठीक है. So again, this is not something that's going to be asked in JEE or NEET directly, but you should know how to convert one to the other. Okay. डरना नहीं आपको इससे. This is physics. I know this is physics, but कर लेना चाहिए. Another question, quick one. A conductance cell was filled with some concentration solution which has a specific conductance. What is specific conductance? देखते हैं. याद है? If the resistance is some value, the cell constant क्या होगा? Specific conductance. What is specific conductance? R was resistance. Rho was specific resistance. So G is conductance and kappa is specific conductance or conductivity. ठीक है, conductance पूरा लिख देता हूं ताकि कंफ्यूजन ना हो, because there is nothing called specific conductivity. इन दोनों को don't combine these two. It's either conductivity or specific conductance. Conductivity, specific conductance. Conductivity, specific conductance. I know the other side over there. ठीक है, cool. 4 options दिए हैं यहाँ पे. ये दोनों का नहीं, अच्छा, they're all different. Maybe we can approximate things. Meter inverse, centimeter inverse. देखते हैं. अच्छा, ये units ठीक लग रही हैं. What is G star? G star, which is cell constant, is L by 8. So yeah, the dimension will be of L inverse, right? This is a dimension. अब वो मीटर होगा सेंटीमीटर होगा देखना पड़ेगा. Here everything is centimeter inverse. So let's see क्या करें. Anybody else giving me this? Ayush, you were right. Why do you track a message? बिल्कुल सही बोला आपने. You were absolutely right. Do you want to try this one out? So how will I do this? Well, I can use the NCERT way. NCERT में तो अभी दिया था ना फॉर्मूला. अभी आपको दिखाया मैंने जस्ट अभी. कहाँ गया NCERT? कहाँ गया फॉर्मूला? Where is it? Where is it? There you go. You can just use this formula, right? Which is R into kappa is G star. That's it. Literally यही करना है आपको. You can do that. You can also do G into G star is kappa. It's the same thing. But if you remember this, you remember it. It doesn't matter which one you remember. And you don't have to remember too many things. आप लोग इसको first principle से कर सकते हैं. On the spot, you can figure it out as well. So it's not that big a deal. So R into kappa is G star. करो इसको multiply. What is 2.8 into 82? मतलब 3 into 8, 21. Okay, great. But 10 power minus 3 and 82. Okay. So now what do we do? 8 into 3 is 21. ये तो ठीक है. 21 मतलब 200 हो गया. Approximately 210 हो गया. ठीक है. 210 into 10 power minus 3 मतलब 0.210. I'm just doing very rudimentary calculation. Okay. 0.210 is what I should get. The one that's closest to that. Oh, now we are. Oh, both these numbers are close. है ना? ये नंबर और ये नंबर दोनों क्लोज है. 2182, 2281. But look at the units. This is centimeter inverse. So don't be scared here. See, now this is a classic example of what would come in JEE or NEET. This is definitely possible. This one. Previous wala, maybe not, but this one is very possible. Yeah. Yes, Mehak, bilkul sahi. Please answer. Yeah, simple. All right. Chalo, let's start with today's idea. What is molar conductivity? मैंने आपको बताया था conductance is an extensive property. Conductivity is an intensive property. मतलब मैं अगर 1 ml लूं या 10 ml लूं, कंडक्टिविटी वही रहेगी. मोलर कंडक्टिविटी इज अनदर टर्म दैट इज अ लॉट मोर रेलेवेंट, क्योंकि मैंने जो बताया ना कि ये आपको, अभी हम लोग जो कंडक्टिविटी की बात कर रहे थे या फिर स्पेसिफिक कंडक्टेंस की, उसके लिए यू नीड अ वेरी स्पेसिफिक सेल, लाइक एक लंबा सा सेल L by A. You don't have those cells. In reality, you have a volume. You have some fixed volume of an electrolyte. ठीक है, तो इसीलिए आई वांट टू नो द कंडक्टिविटी ऑफ अ वॉल्यूम ऑफ सॉल्यूशन, राइट? इसीलिए वी आर डूइंग दिस मोलर कंडक्टिविटी बिजनेस. ओके, so this is defined as the conductance of a solution that has 1 mole of an electrolyte between 2 electrodes which are unit length apart. Length फिर से आ गया, देखते हैं what is this length, unit length. देखो kappa was G L by A, G into G star, है ना? ठीक है, okay. If I just manipulate it in such a way कि let's now write G or take G on the other side. Okay, so G यहाँ पे आ गया. So kappa A by L into L into L. So this now becomes volume divided by L square. Why did I do this? Why did we do this? Because, okay, we can go ahead and say now that the volume of the solution that has 1 mole of electrolyte is this right here, and that is defined as lambda, right? If I take one mole का solution, right, उसकी conductivity is going to give you lambda m. In fact, उसकी conductivity उसका conductance हो जाएगा. So I know it's going round and round, but this is just maths. This is exactly how you define physics quantities also. No, what is F equal to ma? It is the acceleration. What is the force? I'm not that good at physics, so I'm going to avoid physics, but you get the point, right? अगर 1 किलो substance लो और जो जितना acceleration produce करेगा, that's the force, right? That is what you say. This is that same thing here. You put everything else as 1, what remains is this. ठीक है? So now if I take molarity of solution to be 1 molar, why is this blinking? Hold on, I think it has some weird setting on where everything goes to black for some reason and it's bugging me. Let me just remove that. Is it bugging you? It's bugging me a lot. हटाते हैं इसको. क्या क्यों हो रहे हो तुम ये? Transitions. None. कुछ है नहीं चाहिए transition. बैठे रहो. Okay, cool. It was bugging me. It was going to black all the time. Molarity of solution is C, moles per liter. Yeah. Let's get the units of lambda m now or molar conductivity. ठीक है? क्यों? क्योंकि मैंने जैसे बताया कि आपके पास एक सोल्यूशन पड़ा हुआ है, उसका वॉल्यूम है, इट हैज सम फिजिकल वॉल्यूम, एंड आई लाइक टू मेजर द कंडक्टिविटी ऑफ दैट. ठीक है, डू दैट. द इजियर थिंग टू डू, टॉक अबाउट मोलर कंडक्टिविटी. ठीक है, मोलैरिटी सॉल्यूशन इज गिवन बाय दिस. इफ आई टेक सी मोल डिसॉल्व्स इन से 1 लीटर ऑफ सॉल्यूशन, 1 लीटर ना, 1 लीटर क्यों? क्योंकि दैट्स अ कॉन्सेंट्रेशन, है ना? कॉन्सेंट्रेशन निकालने के लिए आई हैव मोल पर लीटर, दैट्स मोलैरिटी. दैट्स व्हाई आई एम टेकिंग 10 power 3 लीटर. तो 1 मोल इलेक्ट्रोलाइट विल डिसॉल्व इन 1000 बाय सी सेंटीमीटर क्यूब सॉल्यूशन. क्यों? आई एम बेसिकली कन्वर्टिंग लीटर टू 1000 सेंटीमीटर क्यूब. This is why in NCERT and everywhere else, this is the formula of lambda m. So it is kappa into 1000 by molarity, and this is important when this has units of Siemens per meter. What is the unit of kappa? Kappa क्या था? R equal to rho L by A. So rho is equal to R A by L. Okay. So kappa was equal to G L by A. हाँ सही था. So Siemens centimeter inverse. This is the unit of kappa. If kappa is Siemens centimeter inverse and lambda is Siemens centimeter square per mole, then you have this formula. This is important. अगर चीजें यहाँ पे if you have things of meter there, yeah, instead of centimeter square, if you have meter square, the formula will be different. What will it be? खुद try करो यार. All you have got to do is convert centimeter to meter. That's all. और क्या करना है? बहुत straight forward चीज है. अब ठीक है, आप लोग नहीं करना चाहते तो मैं कर लेता हूँ. ऐसा यूनिट में C is still more per liter, but this liter I will convert to meter cube. Okay, कितने लीटर होते हैं? 1000 liter equal to 1 meter cube. So 10 power minus 3 meter cube is equal to 1 liter. Just taking this to the other side, है ना? That's all. So we've written that over here. So now 1 mole electrolyte dissolves in 1 by 1000 C meter cube. Oh, look at that. Look at that. Denominator में 1000 आ गया. That's scary. Looks confusing? Don't worry about it. You just got to do it by first principles. मैंने just आपको बताया कैसे. ठीक है? What is Optimus saying? Yay! Good job, Optimus. Good evening to you. बढ़िया. But now this is lambda. Okay. Huh. but this is interesting. That's the formula wala scene. Okay, now just pay attention. This is just math. Okay, pay attention. ये formula की बात होगी. But say I've got the value of lambda. What is this ping? I know my devices are connected. So I'm trying to play around with my phone. I've connected my phone to the computer. I'm going to do some funky stuff at 8:30 p.m. on the JEE channel. We're going to be doing practice, app ka practice. Yeah, really. The Aakash BYJU'S app. Where did it go? I get distracted easily, as you know. This app, can't see it. It's too bright. But anyway, you'll see much better at 8:30. We will do some sessions. So that was when you calculated lambda m in two different units. But say आपने calculate कर लिया, सब हो गया. You don't have to multiply with 10 power 6. Okay. सुन लो मेरी बात ध्यान से. 10 power 6 से multiply नहीं करना है to convert one to the other. It's only 10 power 4 or 10 power minus 4. Why? Why do you think so? Because look here, this 1000 that I am doing is only for this. I have to convert this also ना. कापा भी तो करना है ना? उसका एक और 100 factor आ जाएगा. It's all maths, bro. Please don't mug. What Optimus says was absolutely right. When you're converting, when you're writing the formula of lambda m, there you have 1000 in numerator, 1000 in denominator. But when I have calculated, now I've got lambda m in say CGI units, CGS, CGI is not, and you're converting to SI, the factor is 10 power 4, not 10 power 6. क्यों? क्योंकि भाई कापा की भी तो यूनिट है, ठीक है? Okay, this is maths. If you're uncomfortable with this, do questions. There's no way for me to make you mug this. Questions karo. Let's talk about equivalent conductivity and equivalent conductance. A little bit of an extra idea, not in NCERT, but we should talk about it anyway. We'll just talk about it for literally 3-4 minutes tops. Okay, the conductance of a solution that has 1 gram equivalent of the electrolyte. हाँ, same ही चीज है, कोई बड़ी बात नहीं है. Instead of lambda m, we'll do lambda equivalent. Okay, n is normality. Same चीज हो रही है, 10 power 3, 1000 by n, etc. etc. CGS वाले में ही चल रहा है. We'll do things in CGS itself into 1000 by normality. Now, if you want to do it in SI, same thing, 1000 times हो जाएगा, right? एक minute. We did something funny here. हाँ, 1000 comes in a denominator there. Okay, great. Same, exactly the same, nothing new. Now, how do I convert lambda equivalent to lambda m? Why do you need to convert? I'll tell you. It's insane. It's pretty awesome. See, why do you use normality instead of molarity? Because you don't want to be, क्या बोलते हैं इसको, आप नहीं चाहते कि चीजों को बैलेंस करें, राइट? आपको रिएक्शन बैलेंस करने की जरूरत नहीं, बिकॉज एक मोल इलेक्ट्रॉन विल इंटरेक्ट विद एक मोल ऑफ इलेक्ट्रॉन. सो नॉर्मैलिटी जो इसके मिली इक्विवेलेंट होंगे उसके मिली इक्विवेलेंट होंगे. हेंस दैट वर्क्स ब्यूटीफुली. यहाँ पे भी वही सीन है. I'll tell you कहाँ पे सीन यूज होगा. We'll talk about where is this number will come into the picture, but everything else is exactly the same. हाँ, यहाँ पे instead of per mole you have per equivalent. Okay, what's the relationship between these two? Now पहले relationship निकालते हैं normality और molarity का. You've got n, normality is n factor into m. ठीक है? Now in lambda m में was proportional to 1 by molarity. Lambda equivalent is proportional to 1 by normality. हो गया आपका आंसर, यहीं पे हो गया. Which means कि lambda equivalent will be lambda m by 2 into 2. Sorry, not 2, by n factor. Yes, no, maybe? Give me a thumbs up if this is okay. I'll show you all the proof and all that, but is this okay or does this look weird to you? It could be weird. Maybe मैंने कुछ गड़बड़ी कर दी. देख के बताओ. You have to check. You're watching this video. You also have to participate, at least mentally, if nothing else. Yeah? You're able to see this? Yeah? I'll write this down यहाँ पे. Molarity, for this molarity, this is going to be n into n factor. है ना? Sorry, this is the other way around. It's going to be n factor into m. Cool. So I'll compare both of these guys. You got it, right? You got it. ठीक है. So, if I write the same equations, फिर से, I told you they were proportional, and I do the exact same thing. Here is the maths behind it. You get this. Now, where do we use this? This is the most beautiful part. Where do I use this? Yeah. Let's look at how molar conductivity बदलती है with concentration. I told you about this in the last session. I told you that this is a possibility. It's possible for molar conductivity to be different depending on if your substance. Silent कर दिया जाए. बार-बार बोल रहा है connected. I know you're connected. Okay. It depends on your electrolyte being strong or weak. If the electrolyte is strong, it will behave differently. If it's weak, it will behave differently. In what way will it behave? Well, the strong part is easy, right? There's a person who actually derived the relationship between the concentration of electrolyte and lambda. For weak, it's weird. I'm going to be straight. It's weird. Okay, but let's look at it. Let's look at strong first. Yeah, concentration से बदलते तो हैं. They both change. Okay. देखो अगर concentration कम हुई तो it's obvious that conductivity will reduce. There's no doubt there, right? That's okay, right? There are two things we'll talk about. One is conductivity. The other is molar conductivity. This is a bit different. It is a bit different. This is obvious. This is obvious as to what will happen, right? आप guess कर सकते हो. Molar conductivity, because there's a formula, no, divided by moles, so you have to be careful about it. Be careful. That's all. It's also doable. Use formula. What formula? Lambda m equal to kappa into 1000. Right? 1000 doesn't matter so much right here, but mainly divided by m. This matters. Okay. ठीक है. Let's talk about conductivity because this is the easier one to talk about first. Right? अगर concentration कम हुई तो conductivity कम होगी. मतलब dilution बढ़ गई ना. Concentration कैसे कम होगी? पानी और डाल दो. है ना? This is for both weak and strong electrolytes. Both of them, it will reduce. Okay. Why? Because conductance per unit volume of the electrolytic solution conductivity is conductance per unit volume of the solution, right? Sure. ठीक है. Cool. Now dilute करने पे number of ions per unit volume will decrease and conductivity depends on number of ions, blah, blah, blah. Conductivity decreases on dilution. This is cool. Any doubts on this idea? Is there anything here that seems weird to you? मुझे ये direct लग रहा है, but is there something that you find that, oh, no, hold on, I did not understand this. Please let me know if this is weird to you. Yeah, I'll talk about molar conductivity for a bit because यहाँ पे क्या होता है कि conductivity तो कम होती है, but molar conductivity increases. Wow, did you hear that? That was some crazy auntie kind of a thing. I don't know if you heard that in the mic. You know, good timing. Molar conductivity increases. Okay, this should be conductivity, molar conductance. That makes sense. So it decreases on increasing concentration, और या फिर बढ़ जाती है on dilution. Why? Why? दोनों कारण. For a strong electrolyte, it's obvious. For a weak electrolyte, it is not obvious, right? But if you remember equilibrium, you'll be able to figure it out. You remember dilution में क्या होता था? There was something that happened. You remember this for a weak acid. Let's just remind us of this. For a weak acid, you had K is equal to C alpha by 1 minus alpha, C alpha square 1. याद आ रहा है? Remember this? And then you say, yeah, 1 minus alpha is really small. It's almost equal to 1. Then you said, अच्छा ठीक है. C alpha square is equal to K, so alpha is equal to under root K by C. You remember all these things? You put C here. C alpha then becomes the H plus ion concentration, right? Put then C यहाँ पे ऊपर भी, ठीक है? So K into C, you get this. Oh, and then it looks like, look at that. Yeah. Yes, Mehak remembers this. Mehak remembers यहाँ पे क्या हो रहा था? Let's go back to the alpha वाली चीज itself. Yeah. So the degree of dissociation would increase on dilution. You remember this from equilibrium? ये याद है क्या? C कम होता है, alpha बढ़ जाता है. You remember this from equilibrium? This is what happens with weak electrolyte. Strong is easy. Strong is very, very easy. ठीक है? We'll talk about weak properly. Don't worry. ठीक है? High concentration में weak electrolyte, like acetic acid, has a lower degree of dissociation, and as dilution happens, the degree of dissociation increases. And at infinity, alpha is almost equal to 1. It's all right, Priyanshu. Oswald's law. Thank you, Priyanshu. My sound is not clear. Hi, Survi. Anybody else face this issue? कि मेरी आवाज साफ नहीं आ रही है? Microphone. Is that so? Does anybody else also face this? बता दो जल्दी से. बहुत समय से लोग तो बैठे हुए हैं. Survi, maybe it's your audio that you need to check. Looks like the other folks are saying that the audio is okay. But let me also check. हम बोल रहे हैं तो let's check. YouTube खोला जाए. YouTube. Hold on. Takes a second. Things are supposed to be fast, but I guess not this fast. Clear? Mehak says clear. All right, take your word for it. 2 students saying it's clear, must be clear. Takes a second. Things are supposed to be fast, but I guess not this. हाँ ठीक ही है. मेरी आवाज ऐसी है. That's my voice. ठीक है. So at infinite dilution, alpha almost tends to 1. This you remember from Oswald's dilution law, as Priyanshu just आके सीधे mic drop किया. बहुत सही है, बिल्कुल सही है. One moment, I'm not able to see all the chat. Okay, great. ओके ग्रेट एंड यू नो हाउ इट वर्क्स राइट. अगर कॉन्सेंट्रेशन बहुत कम हो जाता है देयर इज लाइक अ सडन इंक्रीज क्योंकि अल्फा equal to under root k by c. Yeah, you get this here. So if I want to plot lambda m versus root c, अब रूट सी क्यों प्लॉट कर रहे हो? इसमें दिया है ना, रूट सी दिया है यहाँ पे, रूट सी दिया, so we'll do it's okay, chill है, रूट सी के अगेंस्ट करते हैं प्लॉट. there's another reason why we're plotting root c and not c. ठीक है, there's a reason why we're plotting root c. You'll be क्या है bro, if you plot against root c this should be a straight line, right? Like no, देखो I'm not plotting versus 1 by root c. If I plot versus 1 by root c it'll be a straight line. I'm plotting versus root c. Don't get confused by the math. Okay, I'm not plotting alpha, I'm plotting lambda. Okay, these are two different things. There's a reason I'm doing this because for strong electrolytes this is going to be relevant. Okay, इसीलिए मैं रूट सी प्लॉट कर रहा हूँ. ठीक है, cool, we'll look at that just in a moment. So lambda m, which has unit of Siemens, centimeters per mole, centimeters square per mole or meters square per mole, it becomes asymptotic. Now this is where things become interesting. Okay, मतलब कि the whole point of having a graph, by the way, graph हम लोग क्यों बनाते हैं लाइफ में? आपको किनेटिक्स में मैंने बताया था ना, ग्राफ इसलिए बनाते हैं ताकि इट मेक्स अ लाइफ इजी. और अगर मेरे पास 4-5 पॉइंट मिल गए, उसके बाद मैं एक्स्ट्रापोलेट करके पीछे और आगे देख सकता हूँ क्या होगा. अरे यहाँ पे यहाँ कुछ भी हो सकता है, बट दिस ग्राफ इज यूजलेस टू मी. व्हाट डू आई डू विद दिस ग्राफ? अब देखो, इफ आई हैव दिस पॉइंट, दिस पॉइंट, दिस पॉइंट, दिस पॉइंट, और ठीक है मैंने यहाँ लाइन बना ली. अब इसके बाद क्या होगा? इसके बाद यहाँ जा सकता है, यहाँ जा सकता है, यहाँ जा सकता है, यहाँ. इट्स कंप्लीटली यूजलेस. ठीक है, सुनो मेरी बात. दिस इज वेयर द नेक्स्ट थिंग becomes helpful. Strong electrolytes. This is good. Nice linear equation. It increases slowly on dilution, slowly as compared to weak electrolytes. ठीक है. So how does it increase? Concentrated solution में there's a strong attraction between oppositely charged ions. तो इसलिए ions आसानी से move नहीं कर पाते हैं. Let's just take H plus and say Cl minus. अगर ज्यादा ions होंगे then they'll bump into each other. And of course these are not ions by themselves. उनके around they are water molecules. I understand. पानी तो होगा सब जगह, पानी तो भरा होगा, पानी around है. There is hydration happening. I agree. बिल्कुल आपका बात समझता हूँ मैं. But फिर भी even these hydrated ions, if there are too many of them, they'll bump against each other and slows down the movement. That's the logic behind it. Dilution से जो distance बढ़ता जाता है, and after a point it's like, yeah, great, this is awesome. They're like, yeah, influence of other ions is bad, is not good, and that's great क्योंकि gradually बढ़ता जाता है. So much so that I can go ahead and get a value at infinite dilution. Infinite dilution मतलब कि एक ion is just not influenced by another ion बिल्कुल भी. ठीक है, मतलब concentration is approaches zero, almost, बहुत ही कम concentration. ठीक है, इस वैल्यू को हम लोग लिमिटिंग मोलर कंडक्टिविटी बुलाते हैं. एंड दिस इज द ब्यूटी. विद दिस ग्राफ आई कैन फिगर इट आउट. व्हाट ग्राफ? आई विल प्लॉट लैम्डा एम वर्सेस रूट सी. ओके, कुछ कांस्टेंट्स हैं. दिस इज देयर. व्हाट डज दिस लुक लाइक? दिस इज y इक्वल टू माइनस mx प्लस c. ये इक्वेशन क्या हुई? इफ आई वांट टू प्लॉट दिस y x, ठीक है, नेगेटिव स्लोप हो गया. नेगेटिव स्लोप कैसा जाएगा? ऐसा जाएगा, ऐसा जाएगा, ऐसा जाएगा, ऐसा जाएगा, कैसा जाएगा? Doesn't look like this. Probably this. Why? Because this is the positive intercept. Okay. At concentration equal to 0, lambda will be equal to lambda m. है ना? Lambda not m. Lambda m will be equal to lambda not m. So this value is lambda not m. Are you able to keep up with this? This is just basic maths. बहुत basic maths है यहाँ पे. ठीक है. आप 12th grade में हो तो this should be easy to understand. ठीक है. What is the slope of this graph? Slope of this graph is going to be a. What are we plotting here? Root c. खत्म. That's it. This is the graph. This is a straight line graph, and this is nice. I will get maybe 5 points, and they're all forming a straight line. If I plot root c versus this, अब मैं इसको extend कर सकता हूँ to the x-axis. I can get the value of lambda naught. You see why this is awesome, and you see why now. Theoretically, this should be here. क्या बोलते हैं इसको? This guy, weak electrolyte should be like this. Okay, strong SI. Now weak कहाँ पे होता है? I don't know what is a lambda naught. इसका क्या होगा? I have no idea. But we will choose a beautiful way to figure that out as well. Hyperbolic function. Yes, 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 Priyanshu. Bang, bang, bang. Absolutely. बिल्कुल सही बोला आपने. ठीक है. So, if I get this sort of a graph, now it depends on the solvent and temperature and all of this, but it's constant for a particular set. ठीक है. Charges के constant ही रहता है. The value of A, I think when you if you're doing JEE advanced, then इस पे एक दो सवाल आ चुके हैं in the past, yeah, with these graphs itself. It's awesome. They have combined this with thermodynamics. I've done those questions on the JEE channel. आप जाके उसको देख सकते हो. खैर, there are many different kinds of electrolytes. ठीक है, 1:1 electrolyte मतलब कि Na और Cl में एक मोल डालूं तो एक पॉजिटिव और एक नेगेटिव आयन गिर जाएगा. Now I'm talking about strong electrolytes right now. Okay, I can also have weak electrolytes, right? But actually, weak electrolytes, CH3COH, ठीक है. ये वीक हो गया. There is also 1:1 weak electrolyte. But right now strong ones are CaCl2 2:1. 2:1. हाँ, दो Cl minus एक Ca. 2:2 मतलब कि एक Mg2 plus and एक SO4 2 minus. ठीक है. So एक type का electrolyte has the same value of A. This is interesting, not in NCERT. All 1:1 will have the same A. All 2:1 will have the same A. All 2:2 will have the same A. This is theory. You don't have to know this, but just a little bit of extra information. Hey, good evening, Medico ji. Something weird happened today. I didn't talk about it with you guys, but the NEET counseling got postponed. It was quite a shocker. And I thought NTA would announce something, but I read it in the newspaper. Indian Express padha, फिर Mint पे padha. I was sure it's happened. It's crazy. Yeah. Yeah, sure. CSC COH में एक ही वैल्यू नहीं होगी. Yeah, मैं बस टाइप की बात कर रहा हूँ. 1:1 टाइप. You are right. When we're talking about A values, it's not relevant there. Priyanshu, thank you for, अगर कोई स्टूडेंट इसको बाद में notes देखे, will be like, why did he write that? So it won't make sense. But yeah, sure. We are talking only about strong electrolytes. I was talking about types of electrolytes there. I'll tell you why I was talking about types of electrolytes there. ठीक है. And again, some more extra information. अगर dielectric constant ज्यादा है तो A की वैल्यू कम हो जाती है. टेम्परेचर और विस्कोसिटी, टेम्परेचर बढ़ती है या फिर विस्कोसिटी कम होती है, A की वैल्यू कम हो जाती है. Not needed at all, but just some extra information right here. Okay, so lambda naught m हम लोग निकाल सकते हैं for a strong electrolyte just by extrapolation. That's why that graph was beautiful. Weak electrolyte के लिए we need to do something else. Oh, here's a quick question just to check if everyone is awake. मेडिको जी, प्रियांशु, महक, सुरभि, अगर अभी आवाज आ रही है तो इसको ट्राई करिए. ऑप्टिमाइज कहाँ गया भाई? On increasing dilution, all of these will increase. You can have more than one correct. More than one correct. Please try this out. Ideas? क्या वो क्वेश्चन नहीं आता क्या आपको? Ideas? Surabhi is saying all of these. अच्छा. Surabhi, are you sure? Increasing dilution. Good attempt, Surabhi. On increasing dilution मतलब concentration को हम कम कर रहे हैं. अगर concentration कम कर रहे हैं, I feel conductivity कम होगी. What do you think? देखो, conductivity and molar conductivity will have inverse relationship in terms of conductivity, in terms of concentrations. Conductivity is kappa and lambda m is molar conductivity, right? Kappa times 1000 by C when you have Siemens centimeter square per mole. इस यूनिट पे ये होगा. इक्विवेलेंट का नहीं पता, सुरभि क्यों नहीं पता? इक्विवेलेंट का भी पता है आपको. यू नो आइडियाज. अगर वो बेस्ट कोचिंग है तो जाइए वहां पे. कौन रोक रहा है आपको? आप यहाँ पे आए हैं इस क्लास, टेक समथिंग पॉजिटिव आउट ऑफ इट, है ना? टाइम पास करने आए हो तो भाई क्या बोलूं मैं आपको. देन यू आर डूइंग दैट विद योर लाइफ. इक्विवेलेंट क्यों नहीं मालूम? यू नो इक्विवेलेंट आल्सो. हाउ डू यू नो इक्विवेलेंट कंडक्टिविटी? व्हाट इज द बिग डिफरेंस? इक्विवेलेंट कंडक्टिविटी इज द सेम थिंग, kappa into 1000 डिवाइडेड बाय n. सेम ही है. क्या फर्क पड़ रहा है? अगर कॉन्सेंट्रेशन कम हो रहा है डाइल्यूशन में तो नॉर्मेलिटी भी तो कम होगी, है ना? व्हाट डू यू थिंक? आइडियाज, यू आर आल्सो द बेस्ट. बट आप सवाल तो ट्राई करिए. मैं चाहता हूं आप सवाल ट्राई करें. माय फोकस इज स्टूडेंट गेटिंग द गोल दैट दे आर ट्राइंग फॉर, और एटलीस्ट ट्राइंग देयर बेस्ट. गेटिंग और नॉट तो भगवान के हाथ में होता है. यहां पे आओ यार, हैव फन हियर. ओके, द आंसर इज A and C, not this, because that. Surbi, yeah, you understood? Ideas, I hope you understood why it is not D. Ideas? Yeah, आपने D बोला था, conductivity नहीं होगी. Another question. A graph of molar conductivity of 3 electrolytes is given. This is interesting. ये मजेदार सवाल है. NaCl, HCl and NH4OH is plotted against root C. Which of these options is correct? 1, 2 and 3. ठीक है? यहाँ पे 4 ऑप्शंस हैं. यहाँ पे दिख रहा है ना, थोड़ा छोटा मैंने कर दिया, बट दिस इज नॉट वेरी कॉम्प्लिकेटेड. 1 का स्लोप थोड़ा कम है, 2 का स्लोप थोड़ा ज्यादा है, और ये है स्लोप थोड़ा आगे पीछे, स्लोप जो भी हो, वैल्यू 1 की ज्यादा है। स्लोप, डोंट वरी अबाउट द स्लोप, स्लोप इज कंफ्यूजिंग। स्लोप हैज टू डू विद ए, स्लोप को छोड़ो। या ऑलराइट, आइडिया सुरभि, प्रियांशु, इसको ट्राई करो, ट्राई दिस वन आउट। दिस इज सिंगल करेक्ट, नॉट मल्टीपल करेक्ट। लगता है अपने भाई चले गए। डी, गुड ट्राई, गुड ट्राई। तो प्रियांशु, आइडियाज, गुड जॉब। अच्छा, आइडियाज, एक्सलेंट वर्क। आई वॉन्ट टू गो विथ व्हाट आइडियाज इज सेइंग, क्योंकि मेरे हिसाब से देखो फर्क क्या पड़ रहा है। वी हैव टू एलिमिनेट बी एंड डी। क्यों? क्योंकि 3 हैज टू बी NH4OH। ये पार्ट क्लियर है कि 3 हैज टू बी NH4OH, दैट इज क्लियर। ओके ओके, नाउ बिटवीन 1 and 2 फर्क क्या है? I've got Na plus and Cl minus ion. I've got H plus and Cl minus ion. ये मैंने आपको लास्ट वाले सेशन में बताया था कि अगर हाइड्रेशन ज्यादा होता है तो इट मूव्स अ लिटिल स्लोली, फिजिकली मूव्स स्लोली, बट यहां पे आयन छोटा है एंड इट इज आल्सो वेरी फास्ट। नाउ इन द सेम केस इफ आई हैड लिथियम क्लोराइड, देन आप बोल रहे हो सही होता, NaCl ज्यादा होता, बिकॉज Li plus would then be bigger. But this is tiny, bro. Like, this is really, really small. It moves a lot faster. Okay. Hence, iska value is going to be the highest. So this is going to be HCl. This is the logic behind it. अगर गलती से LiCl देते हो, that would be a difficult question. And LiCl will be lower, NaCl will be upper. This is my idea. Yes, mobility, absolutely. उल्टा पढ़ लिया. It's okay, होता है Priyanshu. Don't worry about it. Yes, ideas, Priyanshu and Surbhi, you've all figured it out. Good job, everybody. सही है। So now we are going to look at this idea. मैंने आपको ऊपर से बता दिया कि इनफाइनाइट डाइल्यूशन पे you assume that एक आयन के दूसरे आयन के एनवायरमेंट में नहीं होता है, which means they move by themselves. यही तो अंग्रेजी में लिखा है, कोलरॉश लॉ ऑफ इंडिपेंडेंट माइग्रेशन ऑफ आयन। मतलब हर आयन अपने आप घूमता फिरता रहता है। What is the application of this? That's what we're going to talk about here. That's the name of this session. ठीक है। So what he did, Kohlrausch, he figured out the lambda naught values for many different strong electrolytes, and he figured out some crazy thing like a regularity, right? अगर हम लोग NaX और KX के देखें, right, और उन दोनों की lambda naught values का फर्क देखें, then the difference is almost exactly the same. इन दोनों के डिफरेंस का मतलब क्या हुआ? What is the meaning of difference of conductivities, lambda, not conductivity, sorry, molar conductivities? What is the meaning of difference? मतलब lambda naught M1 minus lambda naught M2, where ज्यादा किसको होगा? सोडियम का ज्यादा होगा ना? सोडियम ज्यादा छोटा है, आई थिंक पोटेशियम ज्यादा होगा। पोटेशियम आई थिंक ज्यादा होगा। पोटेशियम इज बिगर, Na is smaller, but I think hydration की वजह से Na plus gets larger, the ion. This is what I remember from inorganic chemistry. It's wonderful, isn't it? Similarly, अगर ये X, तो एग्जांपल लेते हैं, X मतलब आयोडीन कर लेते हैं। हाँ देखो वही लिखा था, सही हो गया, ठीक है, गुड गुड टू रिवाइज इनऑर्गेनिक आल्सो। सो अगर मैं लूं KBr या लूं Ki, इन दोनों में डिफरेंस वाज द सेम। सो देन व्हाट इज दैट, व्हाट डज दैट मीन? दैट मींस वी आर एक्चुअली इन इफेक्ट कैलकुलेटिंग इन अ वे सेइंग कि लैम्डा नॉट ऑफ K प्लस माइनस Na प्लस, इन दोनों को हम लोग सब्ट्रैक्ट करके बोल रहे हैं। दैट्स व्हाट वी आर डूइंग, बिकॉज इट लुक्स लाइक इसका कोई इफेक्ट ही नहीं है। The anion doesn't have effect. Well, see, look, this is the maths. We are not physically doing something. We are not saying कि bromine को हटा देना है solution से. That's not that. This is just maths. We'll write that in big, just math. Okay, this is just math, but it works. It works. Okay. Wow, ideas. That's a beautiful score. It's a beautiful score. यार देखो, I'll be honest with you. 700 plus में ना, there's a big luck factor. Between anyone who's getting 680, like the score you've got 664, 680 से 700 जाने में, luck is a huge factor, right? आपका उस दिन मूड कैसा है, that preparation, though you pretty much know everything if you're getting a 680 plus score, right? And 664 से 680 किया जा सकता है. I'm pretty sure you got some negative marking. Negative marking हटा दो, you'll probably get to 680. But between going from 680 to 700 is a lot about luck and you being in the right frame of mind to skip questions that you don't know and marking things that you know for sure. That's what I think. Okay. NEET is a very high scoring exam, very different from any other exam that we have right now. Because high scoring है, बहुत ढेर सारे सवाल भी है. Two things, right? See, even IIT is high scoring. IIT जो दिया था Thanos ने and all those guys. But yeah, anyway, we'll talk about that more ideas. Come onto the server if you want to chat about this. Discord server link is in the description and also over here. Okay, so let's get back to Kohlrausch law. Also, what they did was, ठीक है, अगर मैं NaBr और NaCl का लूं, there it was cation different. यहाँ पे anion different है. Anion different करने से भी कुछ constant value आ रही थी. तो it means कि strong electrolytes को लेके we could treat them like math equations, right? What do I mean? What do I mean? At infinite dilution or near zero concentration, when dissociation almost 100% है, each ion makes a definite contribution towards molar conductivity, irrespective of the nature of the other ion. Normally क्या होता है कि देखो NaCl, NaBr उनकी bonding अलग है, right? उनका structure अलग हो सकता है. It's the same, sure, but there's a very different kind of thing. The percentage ionic character is different, percentage covalent character, वो सब ठीक है. But infinite dilution it doesn't matter because the ions are separate, and so it's not affected by the nature of the other ion. This is important, and this is only at the highest, dilution level, which means concentration almost zero. So I can say that if this random thing AXBY dissociates, it gives me XAY plus YBX, then I can say that lambda naught will be the sum of jitne ions hai, moles, right? So I've got X moles of Y plus, Y moles of B minus, multiply that with their respective molar conductivities. यहाँ छोटा lambda लिखा है. This छोटा lambda is Greek, ना? और ये बड़ा lambda है. This is like capital. And this is small. That's what this means. Just like ये delta और delta होता है ना, दोनों delta ही होता है. This is the same thing. ठीक है? That's why you write lambda like this, lambda like this. So for this, it will be 2 plus 3. I mean, obviously, right? 2 lambda Al3 plus 3 lambda SO4 2 minus. Cool. That's it, man. And how is this useful? Because now, same cheese फिर से आ रही है. Sorry. Yeah, even for equivalent conductivity, it's going to be the same. But the difference for equivalent conductivity is we don't care about number of ions. Let me write worry. We care, but we don't worry about number of ions. Why? Because it takes care of it already. N factor may factors for this number. It factors in to that number. Yeah, that's the meaning of N factor. अगर ये याद नहीं है, redox reaction याद करो. Remind yourself that. So this is insanely awesome. And if you are going to be giving even JEE advanced, this is going to help you. अगर वो गलती से आपको इसके बारे में पूछे equivalent conductance बारे में, equivalent conductance में you don't worry about the numbers. Do the math. You'll figure it out. It gets cancelled out. It's crazy. Hey Moon Knight, how are you doing? Hey Ashwini. Hey, what's up Ashwini? Long time. Yeah, I know. NEET counseling got postponed. It's ridiculous. I don't know what they're doing with this. They need to figure this out for you. It's not cool to keep you guys waiting like this. Seriously. Anyway, इसका application क्या है? What is the application of this Kohlrausch law? The application is कि we are going to use this to find out the lambda naught of weak electrolytes. Remember, I know NCERT में diagram अलग है, मैं अलग तरीके से बना रहा हूँ. I don't know where this is going to be. What is lambda naught M here? I don't know. But this I know. This one I don't know. ठीक है? So for CH3COH, NH4OH, we'll do that. Because इसमें जो H plus है, that can come from anywhere. I can say HCl ले लो और CH3CONA ले लो. See, I'll tell you how to get CH3COH. I'll take HCl, I'll take CH3CONA, and I will say minus NaCl. देखो, they're all three of them are strong electrolytes. Why are they all strong electrolytes? Because it's a salt. CH3CONA को पानी में डालो, पूरा dissociate होगा. That is the beauty. So using 3 strong electrolytes, I'll figure out weak electrolyte का lambda value. That's it. Yeah, that's all we're going to do. So यहाँ पे यही लिखा हुआ है. इसको कैसे करेंगे? Technically, this is going to be lambda of CH3COO minus plus lambda of H plus, right? इन दोनों का होगा limiting. But this value I don't know. I don't have to know. It's okay. I don't have to know this, right? I can do it indirectly. So this I can get exactly जो मैंने आपको बताया वही हम लोग example use कर रहे हैं. HCl को ऐड किया, CH3 ऐड किया, subtract NaCl. That's it. खत्म. Okay. All right. अरे वाह, you went to Vrindavan. That's lovely. That's lovely. Hey, Josephine, welcome back. How are you doing? Whoa, that's crazy. You got a really great IIT rank. Hey, counseling IIT की चल रही, आज ही खत्म हुई ना IIT की counseling today. Today was 6th or 7th was आज Saturday. I think today was. Are you going to NICER? Is that the plan? Congratulations. I'm really happy for you. Let me know. Yeah. So we can also use this Kohlrausch law to figure out kitna weak electrolyte dissociate होगा. This is crazy. So two things. I told you that you can find out the lambda value of a weak acid. Yeah, that was the first one. Second application is कि मैं alpha भी निकाल सकता हूं of a weak electrolyte. And this is tested time again. ये NCERT में भी है. Same चीज हम लोग कर रहे हैं. Yeah, weak acid का कर लिया, C alpha and all of that. Now, a little bit of a leap of faith here is कि lambda m is proportional to degree of dissociation. ठीक है, मतलब alpha. तो I will write proportional to alpha looks funny, but ठीक है. Ka is h into this blah 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 blah. ठीक है, पूरा लिख रहे हैं. Just write, let's write the full thing. C alpha square 1 minus alpha. ठीक है. Now I can say that इसको अगर दूसरी तरफ लेके जाएं कि alpha क्या होगा? Alpha is going to be lambda m by lambda naught m. I don't think that इस चीज का what do you call it, proof or derivation is something we can do right now, but this is actually the idea here. ठीक है, ये take it as statement of fact. Okay, अभी take it as statement of fact and this will be good, right? And then Ka, you can substitute all of these things and you get this wonderful equation that is in NCERT. I think it's in NCERT. होनी चाहिए. It's either this form or the previous form that's in NCERT, but I'm just going to quickly check just to make sure कौन सा वाला form है आपकी book में. I know there are a lot of questions in this and I'm doing a lot of theory. Questions आप कर लेना यार. That's something you'll do. इसमें 18 ही सवाल हैं सिर्फ. And उसके अलावा there are 65 questions in exemplar. देखो यही equation यहाँ पे. We just did this. Okay, that's it. That's the end of this chapter. एक दो सवाल कर लें. Shall we do questions? Here's the first question of this topic. अरे दिख नहीं रहा को. Here's the first question of this topic. Light चली गई. This UPS shall last for a couple of hours, so we are good. We just need to do for 15 minutes more. The specific conductance of 0.01 molar solution of weak monobasic acid is some value. Specific conductance या फिर conductivity. मतलब ये है kappa की value. Okay. अरे ये नहीं, ये है kappa की value. ये है concentration. The dissociation constant alpha क्या होगा अगर lambda not दिया हुआ है? डायरेक्ट क्वेश्चन इसका, प्लीज ट्राई करिए. मून नाइट जी क्या बोल रहे थे, पढ़ता हूं. कल लाइन पर कमेंट लंबा था. लेट मी रीड इट नाउ. दैट्स अ ग्रेट स्कोर ब्रो. अरे कुछ डिप्रेशन नहीं है, क्या है यार, लाइफ में यू गेट लेमन्स मेनी टाइम्स यार. लगता है कि यू नो इफ यू डोंट गेट व्हाट यू वांट, इट सीम्स लाइक द वर्ल्ड इज गोइंग टू एंड, बट द वर्ल्ड गोज ऑन एंड दिस ह्यूमन फॉर्म ऑफ लाइफ इज सो प्रेशियस. यू विल फाइंड सो मेनी अदर थिंग्स टू डू. ट्राई किया यार, कोशिश की आपने. अब हालात ऐसे हैं कि समटाइम्स थिंग्स वर्क आउट, समटाइम्स डोंट वरी अबाउट इट. कोशिश करते रहो. ये नहीं तो कुछ और कर लो, उसमें क्या है ना. ये तो बोलने की बातें हैं. आई नो आई एम नॉट बिलिटलिंग योर फीलिंग्स कि आपको लग रहा है यार ये तो बहुत भारी चीज है. आई अंडरस्टैंड इट मस्ट बी डिसअपॉइंटिंग यार. आई वांटेड समथिंग, आई डिडंट गेट इट. वेरी डिसअपॉइंटिंग. मूव ऑन, यू हैव टू मूव ऑन. बिकॉज भाई सब श्लोक में बोला है ना, ह्यूमन फॉर्म ऑफ लाइफ इज दुर्लभ. सो वी गॉट टू मेक यूज ऑफ इट. गुड इवनिंग सुदम सॉरी. कैन यू ट्राई दिस क्वेश्चन आउट. कापा की वैल्यू दी है, ठीक है. विल राइट दैट डाउन राइट ओवर हियर. अल्फा क्या है? अल्फा इज लैम्डा m by lambda naught m. Let's write that. Okay. So lambda m is going to be simply अच्छा. But we know one more. एक और equation मालूम है. ये तो हमको मालूम है, but we know another equation to relate. We don't know lambda, right? इसकी value we don't know, but we can get this. We can get lambda. How? Kappa into 1000 by c. हो गया भाई, खत्म. Question खत्म हो गया. I'm good, Panda. How are you doing? Can you try this question out, please? Ashwini, you want to try this question out, or you're chill? You're like, अभी calculate सब खत्म होगा और नहीं करने सवाल. Josephine Maria ji, you want to try this question out? Ideas? Priyanshu? So from here on, this is substitution, है ना? Kappa into 1000 by c. Kappa कहाँ गया? Kappa था 0.2 into 1000 by 0.01. अरे बाप रे. So into 10 power 3. तो ये हो गया 20 ना? नहीं, 20. हाँ, तो ये तो 20 हो गया, right? So then I'm getting this to be 20. What are you getting this to be, right? Let's put alpha equal to 20 जो मुझे यहाँ मिला by 400 which is 0.05 which is the answer 19. अश्विनी 19 कैसा है आपका? हाय समझा नहीं मैं. 19? Yes, Maria, बिल्कुल सही. 5 10 power minus 2. Panda, what you are saying is lambda m. This is correct. Lambda m is 20. Okay. Alpha is 0.05. That's what I feel. बढ़िया. Done, done, are done. Awesome. So, how confident are you on a scale of 1 to 10 in this chapter? अभी तक जो मैंने आपके साथ किया है उसके लिए how confident are you? Just a quick temperature check. We'll do one more question. Last question for the day. करेंगे इसको सवाल, but tell me, is there anything else that you want me to do to help you with this chapter? Practice हम लोग करेंगे. 9? Maria, awesome, love that. Maria, then let's try this question. 9 is a very good state to be in. Yeah, if you get this, you're sorted. पूरा concepts you know inside out. Lambda m and lambda naught equilibrium, lambda naught m and lambda of oxalic acid निकालना है, given that lambda equilibrium of sodium oxalate and lambda m of H2SO4 is given and lambda equivalent of Na2SO4 is given. तो क्या करेंगे? Let's take this to be 1, 2 and 3. Okay. So what is the relationship between lambda m and lambda equivalent? Lambda naught m is proportional to 1 by m. Lambda naught equilibrium is proportional to 1 by m. Correct? So I can write m to be n factor into m. Right? गलत जगह लिख दिया यार, फिर से बार बार गलत जगह लिख देता हूँ. You will be much better at me than this. Into m. Right? Okay, great. मतलब lambda equivalent is bigger. Okay, cool. So what do we do here? What's the next step? You want to spell it out for you? Arey wah, Ashwini. Good one. What is... Arey... Ashwini has done this question. No, wait. ये तो मैंने JEE session में किया था. Good job, man, Ashwini. That's nice. So, H2C2O4 is going to be H2SO4. I have to add this. I have to subtract Na2SO4 because I want to get rid of SO4. And I also want to get rid of Na. So, I'm going to add this. Okay? So, 1, 2, and 3. Perfect. But on adding all of these three things, here is the small problem with that. Here is a small problem with that. The problem is that this value is going to be 700 by 2. Okay, so it won't be 650. You see that? मैंने अभी तो लिख के बताया था. Lambda m is proportional to 1 by m. Lambda not equivalent is proportional to 1 by n factor into m. Right? Normality मतलब n factor into m. यानी कि lambda naught equilibrium is going to be equal to lambda naught equilibrium नहीं यार, my god, I'm having such. Lambda naught equivalent is equal to lambda naught m by 2. So this is 350. Yes, Panda, I like your Panda emojis as well. So 350 value यहाँ पे आ गई, which means that H2C2O4 now is going to be 350 minus 450. 350 कहाँ गया? 350 minus 450, which was Na2SO4. Correct? This is 3. This is 3. And this was 1. And this was 2 divided by 2. Got it? So this is going to be 300. Ashwini, यही तो मैंने बताया पूरा लिख के अभी. Ashwini, did you forget that part? Lambda naught m is kappa into 1000 divided by molarity. Lambda naught equilibrium. I'm going to shoot myself in the foot if we keep saying that. Normality. Lambda naught equivalent. Right? Normality क्या होती है? This is molarity into n factor. Correct? What is n factor here? It is 2. Right? So, lambda naught equivalent is equal to lambda naught m divided by n factor. which is 1 by 2 into lambda naught m, इसीलिए ये. Got it? Yes, Sudham. बस हो गया खत्म, और क्या बचा है? Now to get lambda naught m, इसका तो सेम ही होगा. lambda naught m कैसे निकाले अब क्या करें? Now it's simple, no? I don't have to recalculate any of this. फिर से I don't have to convert all of these. I can if I want, but I don't have to do that. Good morning. All I've got to do to get lambda naught m is lambda naught equilibrium. Next time I say equilibrium, or just like throw some water in my face. Not on your screen. That would not be good. I'm not sleepy. I don't know why I keep saying equilibrium. Equivalence. Lambda naught. Oh, into n factor, which means 2 गुना करेंगे इसको. Twice, which is 600. That's the answer. Ta-da! Okay, we're good? Any doubts on this? Pretty awesome question, right? Any doubts? Please ask me where there are any doubts. That's it. That's it. That was all I had planned for you for today. ठीक है? Cool. मिलेंगे हम 8:30 बजे. We are going to do app practice of mole concept. It's fun for everybody. And I'll do the same thing on the NEET channel on Monday. NEET और JEE में फर्क क्या है? थोड़ा सा फर्क है. NEET में बहुत ढेर सारे सवाल आते हैं. Usually it is just single application. JEE में एक दो जो है इक्वेशन साथ में आते हैं. Because you said 25 questions 1 hour. Here you have 45 questions in 1 hour. फर्क तो हो गया सवाल. Level is the same. JEE main and NEET का क्वेश्चन का, बट टाइम थोड़ा कम लगता है पर क्वेश्चन. NEET JEE में ज्यादा लगता है, तो क्वेश्चन भी स्लाइटली डिफरेंट. Come check it out if you're free today and also on Monday. Ashwini, my next session is going to be on the JEE channel. चंचल, मैं तो बहुत न्यूमेरिकल्स कराता हूं, पर आपने देखते नहीं है आप. All right, cool. So the way I do things, Chanchal, is I'll do theory and after that I'll do sessions on only numericals, which is what is coming up next week. But good timing, Chanchal. Thank you for reminding me. Advanced तो मुश्किल है, that's true. Advanced तो मुश्किल है. Advanced में थोड़ा effort लगता है. All right, thank you everybody for your time. And if you have any feedback, let me know in the comments, or you can go also to the feedback form on this bento link and give me feedback for my videos on specific videos or generic. And मिलेंगे 8:30 बजे if you want to check that out, and also on Monday on the same channel at 8:30 p.m. All right, or 5 p.m. Whatever time you guys want. What's the time you guys prefer? Do you guys prefer I come at 5 p.m.? Do you prefer I come late in the evening? What time would you like me to take these classes? Comment में बताना. Ping me on iTeachCam on Telegram or Discord. Let me know. It'll be good to hear from you. All right, bye. See you. Have an awesome weekend. Ta-da.